Have you ever wondered what might happen to our solar system in the distant future? This question has perplexed astronomers for centuries. It's a tale of cosmic life and death, of stars being born, aging, and eventually fading away. Our Sun, a medium-sized star, is no exception. It's currently middle-aged, burning bright and stable, but like all stars, it will eventually reach the end of its life. When it does, it will undergo a transformation into a white dwarf, a dense, glowing ember of what it once was. Recently, astronomers came across a fascinating discovery, a white dwarf that is the most massive ever measured. This cosmic gem has a radius barely larger than our moon. Now, you might be wondering, what does this have to do with our solar system? Well, this discovery provides us with a glimpse into the future fate of our own sun and, by extension, our solar system. White dwarfs are the remnants of stars that have exhausted their nuclear fuel. If these remnants exceed a critical mass, they can trigger a type Ia supernova, lighting up the cosmos in a brilliant, violent explosion. In some cases, binary systems, which consist of two stars orbiting a common center, can merge. This merger can lead to supernovae or the formation of new white dwarfs. Our sun won't go supernova, but its transformation into a white dwarf will have profound effects on our solar system. This massive white dwarf's discovery is a game-changer, highlighting the importance of time-domain astronomy in uncovering new phenomena and giving us insights into the future of our home in the cosmos. So, as our sun ages, it will transform into a white dwarf, but what happens next? As our sun transforms into a white dwarf, it will exert a significant gravitational pull. But what might this mean for us? Well, let's delve into the science of dying stars. White dwarfs are the remnants of stars that have exhausted their supply of nuclear fuel. They are incredibly dense, packing a mass similar to that of our sun into a space barely larger than the Earth. This extreme density gives white dwarfs a gravitational pull strong enough to warp the space around them, tugging at the fabric of the universe itself. As our sun ages and eventually transforms into a white dwarf, it too will exert this potent gravitational force, and it's this force that could have dramatic consequences for the rest of our solar system. You see, in binary systems, that's systems with two stars, if one star becomes a white dwarf, its intense gravity can start to pull matter from its companion star. This stolen material forms a disk around the white dwarf, spinning faster and faster until it ignites in a cataclysmic explosion known as a supernova. Now, our sun is not part of a binary system, but as it becomes a white dwarf, its gravitational pull could have a similar effect on the planets and other celestial bodies in our solar system. The gravitational influence of our dying sun could pull these bodies from their orbits, drawing them closer and closer until they're torn apart by tidal forces. These shattered remnants could then form a disk around the white dwarf, similar to the accretion disks seen in binary systems. And if enough material is pulled into the white dwarf, it could trigger a type Ia supernova. This is an explosion so powerful it can outshine an entire galaxy, reducing everything in its vicinity to cosmic dust. So, as we gaze up at the sun, it's worth remembering that one day its gentle warmth could be replaced by a gravitational force so powerful it could reshape our solar system entirely. Therefore, our planets could be pulled into the gravity of the dying sun, leading to catastrophic events. But how can we be sure of these scenarios? Is there any evidence? Well, it seems there is. Enter Harvard astronomer Avi Loeb and his team of alien-hunting scientists. In 2014, they made an intriguing discovery: metallic remnants of what appeared to be an interstellar object, which they named IM-1. This object had crash-landed in the Pacific Ocean, and its initial analysis unveiled a fascinating secret. These tiny metallic spherules contained an excess of elements when compared to other stony meteorites, indicating a likely interstellar origin. But the story doesn't end there. In a study conducted by Loeb and Michael McLeod, it was suggested that the properties of IM-1 could be explained by tidal disruption of rocky planets around M-dwarf stars. To put it simply, they theorized that scenarios where rocky bodies get torn apart by white dwarf stars could potentially explain the origin of IM-1. This theory paints a vivid picture of the volatile nature of space and the life cycle of stars and planets. The team is not resting on their laurels, though. They're planning further expeditions to the IM-1 landing site to find larger pieces and determine whether this interstellar object was natural or artificially made. They continue to analyze the retrieved spherules for isotopes that could help date the material and give us a better understanding of its journey through space. So what does all this mean for us and our solar system? It's evidence that supports the idea that our solar system could be pulled into the gravity of a dying star, torn apart and ground to dust. It's a stark reminder of the transient nature of celestial bodies and the fact that our solar system too has a life cycle. So it seems that the fate of our solar system might well be written in the stars. But what if the remnants of these cosmic events have already reached us here on Earth? Imagine strolling through the Egyptian desert and stumbling upon a stone that's not just an ordinary rock, but a relic from a supernova explosion. This is precisely the story of the Hypatia stone. Named after the renowned female philosopher of ancient Alexandria, this stone is believed to have originated from a supernova explosion, a powerful and luminous stellar eruption when a star has reached the end of its life cycle. Now you might be wondering, how do we know this? Well, chemists at the University of Johannesburg analyzed the Hypatia stone and found that it contains elements consistent with a type Ia supernova explosion. This type of supernova occurs in binary star systems when a white dwarf star accretes matter from its companion star, eventually leading to a thermonuclear explosion. What's even more fascinating is that the stone's composition differs significantly from anything found in our solar system or the Milky Way. This indicates its extraterrestrial origin and further bolsters the theory of its birth from a supernova explosion. But why does this matter? This discovery is of significant importance because it could provide the first tangible evidence on Earth of a supernova-type Ia explosion. This explosive event is not just a spectacular celestial fireworks display, but it also plays a crucial role in the formation of elements in the universe. Understanding the Hypatia stone and its origins could potentially shed light on the formation of our solar system. It opens up new avenues of research into how these celestial cataclysms might have influenced the birth and evolution of our home in the cosmos. So as we look at the night sky, it's worth remembering that we're not just spectators in this cosmic ballet. We're part of it, and pieces of its history might just be lying at our feet, waiting to be discovered. These interstellar souvenirs, like the Hypatia stone, might be telling us a story of cosmic events far beyond our current reach. So, what are the unpopular facts about the fate of our solar system? Well, the lifespan of our sun, like any other star, is finite. As it exhausts its fuel, it will expand into a red giant, potentially engulfing our closest planets. Its ultimate fate, however, is to shrink into a dense remnant known as a white dwarf. Now, this is where things get interesting and somewhat unnerving. The gravity of this dying star could be so immense that it pulls our solar system into its clutches. And what happens then? Our planets, asteroids, everything we know could be crushed and ground to dust. It's a dramatic end, isn't it? But before you start panicking, remember this is not going to happen anytime soon. In fact, we're talking about a timeline that spans billions of years, and as far as we know, humanity will have long since left the building. Yet these unpopular facts have a silver lining. They are driving scientific research into high gear. The discovery of interstellar metals in the Pacific Ocean and the mysterious Hypatia stone found in Egypt might provide us with tangible evidence of the violent ends of other star systems. By studying these remnants, scientists hope to gain insights into the future of our own solar system. Moreover, the detection of the most massive white dwarf ever measured, barely larger than our moon, is shedding light on the fate of stars like our sun. Observations of these celestial bodies help us understand the cosmic dance of life and death, the creation and destruction that defines our universe. While these facts might be unpopular, they are fascinating reminders of the dynamic nature of our universe and the ongoing mysteries it holds for us to uncover.